Hey, how are you? Welcome everybody. So good to see you here today. Today we are going to study the three forms of a quadratic, and we're going to learn what's that fundamental thing you're supposed to get from each one. But before we begin, I have a little motivation for you. And that's a moose, right? See, I wrote it just in case I forgot what I drew. All right, so you can do this. Let's talk quadratics, all right? So if we're talking quadratics, we're really talking about the kind of function that creates a parabola. Knew I'd find the right words if I stumbled over it enough. So let me draw you a parabola. All right, let's see. There's lots of different ones I could draw. There we go. So when we look at a parabola, a few points probably should stand out. All right, this point, that looks pretty special. These 2 points look special, and so does that point. And each one of these forms will kind of highlight, if you will, one of these attributes. So these x-intercepts here, we're going to get really easily from intercept form. So when it comes to intercept form, we're going to be thinking x-intercepts, right? The other super critical point is the vertex, right? The center of the parabola, the center of that symmetry. That, probably not surprisingly, is from vertex form. Vertex form gives us the vertex. Who knew? I know, right? You're like, damn, Mr. Miller, was that you or was that an angel? All right, there we go. That's the vertex. And then this is the y-intercept, which is given by standard form. But the y-intercept is pretty easy to find no matter what, so we'll save that one to last. But let's start with vertex form. Let me write up a few equations, and let's practice finding the vertex using mathematical structure. Let's get it. Okay, well, I think we're ready. So quadratics are a lot about mathematical structure. It's about seeing the shape of the equation, the shape of the function, and from that shape, kind of determining characteristics of the parabola. So this is a critical shape, and it's called vertex form. So up here's the general vertex form, which says if you see a quadratic that is a square plus a constant, and the outside is multiplied by a value, which could be 1, by the way, and that value there is a 1, so the coefficient of x is 1, so I can't put any old number in there, it's got to be a 1. The vertex is automatically at HK. That should be without calculation. Kind of like when you probably in your past have looked at an equation like that, and when your teacher said, yo, what's the slope? You didn't break out your calculator. You just looked at it and said the slope is 3. When your teacher said, what's the y-intercept? You didn't go online and break out Excel. No, you just looked at it and said, that's the y-intercept. It's 1 because you knew of this structure called y equals mx plus b. This is the same idea, except the structure, of course, is a little bit more complicated, but good news. You can do complicated things. Yes, you can. I believe in you, so let's go. My goal ultimately is that this doesn't become complicated, but let's see. All right, so here, the h value, and I'll switch to pink here. H must be 3. That's the h value. It's going to be 3 because it's subtracting h, subtract 3. The k value has got to be 4. So therefore, our vertex is going to be located at 3, 4. Holly, give me a high five. Give me a fist bump. Let's get another one. All right, so here it is. Again, same structure. One thing I noticed that's different is that I have a plus. I also noticed I got this 2 out here. But the 2, look, even in the structure, it says the vertex is at H. It doesn't matter what the hell A is. A can be whatever it wants to be. If it wants to be a 2, be a 2. You want to be positive, A. Doesn't matter. This value don't matter, so I'm going to ignore that 2. Well, this value does matter, so because it's a plus, that must mean H is actually negative. Because when you subtract a negative, you add. So if it's represented as a plus, H must be negative. We go over here. Similarly, right, so K must be negative. So we're going to go -1. Oh, I already dropped 1 marker and I barely started. So here we go. Now we're going to have a vertex at -2, -1. So this is just using mathematical structure. If you conceptually know what's going on, the vertex is always when the square is 0. So -2 happens to make that 0. And when it is 0, y is -1. It kind of just all makes sense, I guess. But let's stick to mathematical structure. Okay, 3. Vertex. I got to make sure I turn this thing on. I'm feeling like I didn't turn it on. Okay, I did turn it on. That's good. That's good. Sometimes it's happened where I've forgotten to turn it on. All right. So now I want you to write an equation that has a vertex at this location with a equal to 1. So if a equals 1, I'm going to replace a with a 1. And now if the vertex has to be at -3, then it's got to be x minus -3 squared plus 2. But now I'm going to erase this because we don't do minus negative. Come on, we're not going to do minus negative. We're just going to call that positive. Because when you minus a negative, that's the same as adding. It's true in math and it's true in your life. When you take away negativity, you become more positive. Well, it's the same thing. When you subtract a negative, you're adding, all right? So this is vertex form. So the baseline in quadratics, if you get in vertex form, you got to nail the vertex right away. That's the start. All right, let's look at the other form. All right, let's go get it. So this is going to be intercept form. So the baseline with intercept form is you got to be able to look at it and kind of immediately get the x-intercepts using the structure of intercept form. So what is that structure? Well, it's a factored form. So it's a multiplication of 2 terms, and then you still have the a value functioning the same way as it's going to function in every one of these forms. If that happens, the x-intercept is immediately at p0 and q0, all right? Coincidentally, those are the values that make the parentheses 0, and 0 times anything is 0. So they're going to be the values of x that force y to be 0. All right, well, let's look at it. Number 1. So here, the p has got to be 3. So I already know one of my x-intercepts is going to happen when x is 3. So I'm going to go 3. That's going to force y to be 0. Right? When you plug in 3, y is going to become 0. Now my other x-intercept can be found over here. Because it's an addition, right, and our mathematical structure is of a subtraction. Yes, it is. Mr. Mill, why'd you find that so exciting? I don't get it. Hey, it's supposed to be a subtraction, right? Well, here's an addition. So that must mean that q is actually -4. Because if we're to subtract a negative, that's the same as adding. So what I'm going to do here is I'm going to go -4, 0. Yes. 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 All right. Hey, I like this. Let's see. I like how I'm feeling. What I want you to feel, at least, is a sense of ease with it. So let's try the next one. Oh, I got this number 4. But you know, up here, it didn't matter what the hell a was. It could be whatever it wants to be. Beautiful thing about a variable. So I don't care that that's 4. It don't matter. It does not matter. At the end of the day, P is 7. So when x is 7, this is going to be 0. And 0 times anything is 0. So let's just keep it rolling over here. So we're going to go 7, comma 0. Might as well even just set up the rest of it. Now over here again, it's a plus. A lot of my students, they always tell me, well, oh, take the opposite, take the opposite. That's what they like, take the opposite. Hey, if you want to think about it like that, go ahead. Because taking the opposite is how you get to 0, you know? Taking the opposite is how you get to 0. That's ultimately what we're doing here. All right, number 3, x-intercepts. We got them at -7, 0. We got them at 5, 0. I'm going to check my battery. Oh, we still good. We still good. All right, let's go. I got where my x-intercepts need to be, and I want a to be -1. I want to write that equation. Well, let's get after it. So I'm going to go y is equal to -1. Just write the a value right where it's supposed to be. Okay, -7. So I'm looking kind of at our previous examples, and I realized that when it's plus, the intercept's at a negative, and when it's a minus, the intercepts are at a positive. So if -7 is to create the 0, or if p is going to be -7, well, minus a negative is positive. So you can either think about it like that. You just plug in -7 here, and minus a negative is positive. Or you ask yourself, if -7 is going to create a 0, then I got to be adding 7 to x. That's the only way for -7 to become 0. Over here, 5, that must be the subtraction, so we're going x minus 5. And there you go. So intercept form, right away you want to look at intercept form and write those x-intercepts. That is the ground floor of intercept form. Look at intercept form, use mathematical structure to get the intercepts. Only one form left. All right, well, let's finish up. Are you tired? Don't be tired yet. I see you. I see your eyes. You know, don't be tired yet. Go get that cup of coffee if you need it. All right, so let's look here. Standard form is it's kind of the least helpful because there's no special grouping that's happening here. It's just like the quadratic all multiplied out. Here's what it is. Here's the quadratic term, the linear term, and the constant. And so the information that it gives us, which I didn't write up here, is that the y-intercept is located at 0c. Which makes sense because if you make x 0, 0 plus 0, y would have to be equal to c. So let's just go get it. All right, so first one here, I would just practice always figuring out a, b, and c no matter what, because it'll be helpful when you do things like the quadratic formula. So a is 1, which of course doesn't matter for the y-intercept. B is 2, also doesn't matter. And now C is 1, which means that our y-intercept, which is going to be the value of y when x is 0, is 1. And I would represent it as a coordinate point. I'm pretty confident your teacher's going to be okay with that. All right, let's move down to the second one. Let's write A is -4, B is -3, and C is also -3. How about that? All right, so what does that mean for our y-intercept? Well, it's always the C value. So we're going to go C and -3. All right, let's put a check mark. Hey, that was fast, but the point really for me on this video is to realize what is that characteristic that you can find from structure without any calculation. I didn't calculate anything in this video. So vertex, you should find the vertex without calculation using structure. Intercept form, you find the x-intercepts. And standard form, find the y-intercept without any calculation. Which also means that if you have intercept form and you want to find the vertex, it's going to require some calculation. If you have vertex form and you want to find the x-intercepts, it's going to require some calculation. But that's a different video. Anyways, I hope you learned something. I hope you're feeling good. Right now, you deserve that. You deserve to feel good. I gotta go. It's a beautiful day. It's also a Friday, okay? So stay hip and be kind to each other, and I'll see you around.